So this is the fifth in a series of discussions around the economics series of products on biodiversity modelling. So before we get started, just like to acknowledge the traditional owners and the lands from which we meet and the lands that we're going to talk about, and pay my respects to elders past, present and emerging. So today's session is about biodiversity modelling. Although I'll put the caveat up front, it's not really about biodiversity modelling. It's about trying to take our first mini step into being able to try and quantify some biodiversity benefits from NRM activities. So here a really quick background for those who haven't seen the previous sessions. So the economics platform's got 4 parts to it. Economics plan. So this is about investment prioritisation, coming up with portfolios of investment, and that's what we're doing in this first round of activity. That'll lead into economics project, which is a farm scale tool for capturing individual projects and modelling them more precisely. And then economics reports, so to be able to communicate to impact reporting around those NRM activities, and economics markets, so to facilitate getting these projects into marketplaces to allow investment into NRM activities. So we're going to focus on economics plan in this session. So economics plan is a sub-catchment level lump modelling approach for doing rapid portfolio generation. It's for investors to be used by investors and NRM bodies and local government authorities. And what we are trying to have here is a consistent approach across large spatial scales so that we can share the concept of actions, and we'll get to what actions are in a minute. And it's limited to data and approaches that can be applied across large areas. And we're basing it on what we've done previously in the Reefonomics tool, and including both quantitative and qualitative measures. So this economics plan, we've got about 150 different actions, and those actions represent agricultural practice improvement or interventions like revegetation, plus the associated support mechanisms that go around that on-ground action. So the extension work or grant schemes and the like. And it's a big list of the sort of broad types of actions we've got there. So across a series of industries, as well as the more traditional riparian revegetation work, and it's a large list. Let's move on though. I want to just give some context though for economics plan within the context of economics project. So economics project, which is coming up after economics plan, is a farm scale modelling application. So we can deal with very locally specific data sets and information, and it's really building on what we've done in the reef space and a product called Paddock to Reef Projector, where we capture agricultural practice improvement type work. So for today, it's about the high level economics plan, but with a view to being able to think about the more specific and more accurate implementation that we might do an economics project coming up. So there we go. First the economics plan, then economics project. And what these two things share though is this concept of an action does work on a measure, and then ultimately measures combine to report on our overall values. So economics plan, the way the actions work on the measures, they're very computationally simple. And then economics project, we can have much more complicated and locally relevant farm scale modelling there. So let's think about actions, measures and values. So here's an example. We've got a community driven riparian revegetation program focusing on connecting songlines, so places of connection for First Nations people, and that might impact on a measure of increased riparian vegetation. What we care about today is how do we represent the biodiversity value that might imply. So expand that out a bit more. So the same action and we think about all the different measures that might impact upon. Now, the areas in light here are things that we're representing in a semi-qualitative way. We're using a Likert scale approach from a large negative impact to a large positive impact, and just scaling that out. The water quality measures we've largely dealt with elsewhere, and we deal with that in a quantitative way. What we've done previously in Reefonomics is the biodiversity measure was one of these Likert scale measures, and what we hope to do here is move it into a more quantitative representation. So, and that's what I want to talk about today, really. There you go, that one. So, thinking about how things work in economics plan, the base approach is we've got, we call it the base data. There's an area available to do work, so an available length of stream that we might do revegetation on. And then there's the measures we care about, and those measures have got an initial base condition, which might be a load or a condition or the current area. We apply the action, so that action gets applied over the area, and there's an impact of that action on each of the measures that we care about. It can have a big impact, a small impact, or a negative impact. So then we apply some accounting, reduce the available area to do works, because we've revegetated some riparian zones, so that reduces the available riparian area to do future work on, and then we do accounting on each of the measures that we care about. So what's also going on in here is the concept of confidence. So we've got confidence in the underlying base data, and we've got confidence in our ability to predict the impact, and that gets combined as well to produce an overall confidence in our predicted impact. And we talked about that in an earlier session on Monday, so if you're keen on that, it's back on the video from Monday. So how do we do this quantifying action effectiveness? So for the quantitative approach that we've used for the water quality improvement prediction, we've got 3 different ways of dealing with it, and this is really all about quantifying a load change. So these water quality parameters, load changes, and we do a fixed change, so a total number of tonnes, a yield change, a load per area or a load per length for linear features like gullies and streams, or an efficacy-based approach, which is a proportional reduction. And that seems to work fine for our water quality elements. Now, been trying to think about how to represent potential biodiversity values. So I don't propose that we do any biodiversity modelling in this early stage, but to use vegetation as a proxy for biodiversity, and the area of riparian vegetation, wetland vegetation, and terrestrial vegetation. And the reason for doing that is there are great data sets, particularly in Queensland, that cover vegetation and where it exists and what class it is. So it's about being able to build on that. So what we propose here is that actions such as revegetation can increase the area of vegetation. So effectively, we're just having a score of increased area of vegetation, and then within that, being able to quantify the class or the value of that vegetation. And we'll seek some input on how that might be done. But initially, we just want to tick off on this idea of just being able to represent changes in area. Now, a really important consideration, and applies particularly to vegetation and biodiversity generally, is the concept of avoided destruction. So we typically do this very poorly when we think about planning NRM. We plan NRM and think about doing new stuff, but we don't worry about the avoided destruction. So the value of being able to protect high value areas, it doesn't seem to have a currency. And I guess because it's not additional, but it's super cheap and it's super valuable. So we're trying to come up with a way to try and represent the value of avoided destruction. So our proposed approach here is to use a business as usual approach, where effectively we have business as usual actions, which are effectively a continuation of the current status quo. So for vegetation, look at the recent rates of clearing and apply that as a business as usual action will be a continuation of the recent rates of clearing. And so in that case, we could have avoided destruction are actions that effectively increase the area and consider that as additional. So as long as the continuation of clearing is greater than the area that we're going to protect, then the mass balance still works. So we're not having a we're not going to increase the available or the total revegetated area to be more than 100% of the available area. Pretty keen on feedback around that and how to handle it, and if others have done it in different ways. So that's our quick summary of how we want to approach biodiversity quantification. We've got upcoming meeting on Friday talking about biophysical data, particularly in the southern Queensland landscapes, so Queensland Murray-Darling Basin region and southeast Queensland. And then a follow-on meeting on Monday about the data that we might use to implement what I've described about representing the biodiversity components. So I'm going to post this video along with the videos for the other sessions at economics or eco-nomics.net.au/videos. So you can come back and have a look at it or share it with others who couldn't attend. And so thank you. So that's the summary presentation, and we might end the video there and take questions.